And to build that central access point, we'll use this, our outdoor PoE pass-through switch. So on paper, parking lot security is easy. You draw a field camera icon on a map, draw some lines, plug everything in, done. But in real life, it's usually the messiest part of the network. Too many cables, not enough power outlets, and someone always ends up trenching twice because the run was just a little too short. So in today's video, we are going to simplify parking lot security. So our client runs a mid-sized logistics yard. Trucks come and go 24/7, so they needed cameras on entrances, loading bays, and the far corners of the lot. Their original idea was the traditional way. Each camera's home run back to the building. Separate conduits, separate power outlets, scattered around the lot. On the drawing, that may look fine. But on real sites, it means multiple trench, multiple AC circuits, and every extra meter of copper adding cost, power loss, and headaches. So we asked a different question. Instead of bringing every camera back to the building, what if the parking lot has one clean, centralized access point? So rather than 10 separate cables runs, we send just one high-power PoE from the office to the middle of the parking lot. And to build that central access point, we'll use this, our outdoor PoE pass-through switch. So this switch is waterproof. It has an IP67 rated metal enclosure designed to live outdoors on a wall or pole in rain, dust, and wide temperature ranges. And it's powered entirely by PoE from the building, so we don't need an AC outlet next to the pole. And inside, it gives us one PoE pass-through uplink port from the main network and up to 7 gigabit PoE ports for cameras and other devices, with a total PoE budget of up to 95 watts. Another neat trick is, when you fit it with a PoE++ source, it can effectively stretch your PoE reach up to about 200 meters in total by splitting the run into two segments. First 100, we run from the building to the PoE pass-through switch. Then we can add another 100 meters from the switch to the furthest device. So how do we put all of this together on the site? Let's walk through the installation. So step 1 in the network room, we're going to add a PoE++ source. That can be a high-power 802.3 BT injector like this 90 to 95 watts mid-span, or you can swap to our PoE++ switch that support 802.3 BT on the uplink port. Now this device sits safely indoors on a standard AC power and ties into the existing network. Now I'm going to use a short patch cord to connect from the data input port to the switch at the control room. And you can see the switch is already connected to NVR to display video. Then I'm going to use this 100 meters Ethernet cable, connect to the PoE output port. So step 2, from that PoE++ port, we run a single outdoor rated Cat6 cable out to the center of the parking lot. It carries both data and up to around 90 to 95 watts of power to our outdoor waterproof PoE pass-through switch. So step 3, we already mounted the switch on a wall about head height. There's no extra AC wiring is needed here. This switch is PoE powered. So I'm going to connect the 100 meters Ethernet cable to port 7 because this is our PoE input port. So now we can fan out shorter Cat6 run to each IP camera's access point and sensors around the lots. I already connected to 3 Ethernet cable here. And each device can get up to 30 watts, which is enough for most fixed camera and many PTZ model. We have 3 cameras, 1 PTZ and 2 bullets. Now you can see they're running. That means they're getting power and data already. Here we go. I'm going to wave my hand so you can see. We are getting live video feed. But our logistic client had one more challenge. They wanted coverage at a remote gate almost 300 meters from the building. Copper Ethernet and PoE have a practical limit of about 100 meters per segment. Push it much further, and the signal quality drops and the power loss becomes serious. So the big question was, what if we need ultra long reach and there's no AC power at the remote gates? Can we still get cameras and a switch out there without building a whole new power circuit? And the answer is yes, by using fiber for data and copper just for power in a single composite fiber optic cable. A composite fiber optic cable combines fiber strings and copper conductors in a single jacket, and the fiber handles high-speed data up to 10 gigabit per second over hundreds of meters, while the copper cores carry DC power to the remote switch. So in the building, you have your power supply and network gear. Then you can run a composite fiber optic cable out to the remote gate. So let's build our 300 meter setup with composite fiber optic cable. At the control room, we're using this WebSmart PoE switch because this one has an SFP slot, so we can plug in our SFP transceiver to connect with the fiber optic cable. First, I'm going to run a fiber patch cord, because we're connecting the fiber patch cord to our termination box, so we have a clean setup. This termination box is also connected to our power supply. So inside you can see our composite fiber optic cable is come pre-terminated, factory tested, and designed for outdoor use with a protective shield against moisture and UV, support multi-gigabit and even 10G speed, which future-proofs your link as camera resolution climb. We can see everything is connected. Now we'll run this composite fiber optic cable first to an outdoor surge protector, because this is an outdoor setup, so we should ground everything and protect our gears. We have the surge protector and a power circuits, and we already connect the power conductor through it. Then it will run a fiber patch cord and the power cord directly to the switch at the far end. This time, we mount a different type of switch. The 8-port L2 Plus managed outdoor PoE switch with 36 to 60 volt solar input. Now this unit also lives outdoors in an IP67 IK10 vandal resistant enclosure with 8 PoE ports and 2 SFP fiber slots. So now we can see our fiber patch cord is going to connect to the SFP transceiver into the SFP slot so we can get the data. And the power cord is already connected. It's designed to accept a DC input in 36 to 60 volt range, including solar system, and then distribute PoE to our cameras. We're still connecting to 3 cameras, so 3 short patch cord. So it's built exactly for a remote spot like this far gates. That one box then powers and connects all the cameras at the gate. So now we can see our monitors. It's already getting live video feed. I'm going to wave my hand. Now we do have to think about voltage drop over those long copper runs in the composite cable. Our 36 to 60 volt input range on the outdoor L2 switch gives you flexibility, so you can start with a higher DC voltage, knowing you'll lose some along the way and still land inside its safe windows at the far end. And to size things correctly, you can use a voltage drop calculator online. Just type in your cable length wire gauge, current draw, and supply voltage, and the tool will show you how much voltage you lose so you can confirm you still have enough at the switch. And this is where cable gauge matters. Thicker copper, which means a lower gauge number, has less resistance. If you choose a composite fiber with, for example, 23 gauge power conductors instead of something thinner, you can deliver significantly more power at long distances. And in our case, a 23 gauge composite cable can still provide around 80 watts at roughly 300 meters, which is enough to run the outdoor PoE switch plus servo cameras comfortably, as long as you budget your PoE loads. Adding good practices, you should use UV resistance, outdoor rated Cat 6 copper cable and keep connections sealed with proper glands. And always ground your outdoor switches and metal enclosures to bleed off static and protect against surges. Then you get a clean, centralized parking lot security system that's easy to understand and simple to grow. And if you're planning your own parking lot build, feel free to drop your layout in the comment section below. We might turn your design into our next video. Now, thank you very much for watching, and I'll see you in our next one.